Well, hello everybody. Thanks so much for everybody that could come here and take a look on this that I'm going to show you. So let me get started by introducing myself. Daniel already said a little bit, but let me expand that a little bit. So I'm Eric. I come from Brazil, and I work at Very Good Ventures as a tech delivery lead for the past 2 years. I'm also a member of the Flame team. I have the honor of saying that I'm the second member of the Flame, so I have been for 5 years working on that project with some good friends that are here. Say hello, Flame team, yeah. And I have my own initiative of developing games, so I build some games on my free time. If you follow me on Twitter, you might have seen some of the work that I have done. And I'm gonna do a shameless plug here. There is a game that I developed that is on the partners area there. So it's a cooperative game, 2 players can play at the same time. So if you have time and want to give it a try, please check it out there. And what we're going to talk about you today. So I'm gonna tell you a brief story of how we developed the IO Flip game. So who have played the IO Flip game? Oh, a lot of people also. So for those who does not know, I'm going to show a little bit what this game is, but a quick summary is that this was a showcase project that we did for the Google I/O event on early this year, on May, if I remember correctly. And awesome. So I'm going to talk, this will not be a very technical talk. I'm going to mostly show you the story, the challenges, things that we learn, and all those stuffs. I'm going to show a little bit of the technical bits of the project, like the decision that we made, why we made those decisions and things like that. And we are going to open for questions in the end. So this is the game. So basically, it's a card game where you can start it by selecting some terms, right? So, and those terms will give you a deck. From that deck of 12 cards, you can select 3 cards. And with those 3 cards, you get to the game. It finds an opponent for you. And when it gets to the game, it's basically a simple card game. So each card has their power. You see that they have an element. So in this play, you see that both cards are fire, so the element does not play much a role. But if you play, for example, this earth card, I don't remember what the other one. A water. So water has an advantage over earth, ground, I don't know. So it deals more damage, and then the water card wins. So that's the basic of the game. It's super simple. It has a power, it has an element, and the card who has the biggest value once the elemental damage is done wins the round. Whoever wins more rounds wins the match. So that's the idea of the game. And every time that you play, you get a new card. You can play this as many times as you want, and yeah, that's it. That's how IO Flip works. And I'm gonna tell you a little bit how the idea of that game came, because this was a very different part of the project that I personally didn't experience much. The ideation of the project, because we didn't have much requisites in the beginning of the project. When Google approached us for this project, we have very little requirements. We'll also talk a little bit about. So yeah, that's what I'm going to start talking. How was the ideation of this project? And first, I'm gonna share a little bit what was the requirement, because every time we do an IO project, we have some requirements and to try to follow the goals of this showcase, right? So we have a classic checklist for those projects, and usually it needs to be fun, because, well, it's a game, it needs to be fun, otherwise you will not want to play it. And since this game is released on the I/O event, most of people will be playing on their mobile browsers because they are doing the event. So that's a very strong requirement to have for the project. It needs to work on mobile browsers, both Android and iOS. And this is also, again, a game to be played in an event, so it shouldn't be like Baldur's Gate that have 30 hours up, because people need to pay attention to the event. So it should be a short game, but replayable, because if it's just short and you cannot replay, what is the point? You're gonna spend 30 seconds in it, then it's done, whatever you spend 3 months making this. And so you have to have replayability. And of course, it's a game made to showcase Google technology and services. So we have to use Flutter, Firebase, Cloud, basically whatever we can fit in the game to make it work, to build the game with Google technologies is a requirement that we have. But this time we had a very unique requirement. We should include machine learning. And this, when the project came to us, this was the only guideline that we had from Google. Like, we didn't have any like, this needs to be a card game, this needs to be a platform, no, it must include machine learning. That was all the information that we had. And it was a nightmare because everybody wants to creating games. I don't know from any of you, like, if you ever create a game, but it's so fun to create a game. Fun is all about the games, right? So we have many ideas, and everybody has different ideas, and we have so many of them. So in the beginning, we spent like weeks trying to think to narrow down the collection of ideas that we had from all the team. In the end, we were able, after a couple of weeks, we were able to narrow to 2 ideas. So the first idea that got a lot of attention was, probably you know, I don't know, I think it's where is Aldo in English. In Portuguese, it's where is Wally. But that came that we need to Waldo, right? Yeah. So the first idea that we thought was to create kind of where is Aldo game, where instead of Waldo, we would use Dash and Spark, and they would be in a crowd, and the sprites from Dash and Spark would be generated by generative images models, and basically the player would have to choose, not choose, sorry, to find where a specific version of Dash were. And another idea that got a lot of attention would be to build a card game, because, well, card games, we can make it multiplayer. Cards, you know, also have illustrations. They also have text, descriptions, so we could use those generative models to do that. So also, that was the two ideas that got attention. And we built some prototypes. So this is a very quick prototype that I built for the where is Dash idea. So there's no machine learning here, it's just the game mechanics idea. But yeah, this is illustrated well. So we'll have a lot of Dash, each Dash would be a variation of them. I don't know if anyone remember Dashatar, but this is the sprites from Dashatar from a couple of years ago. And yeah, this summarizes what this where Dash idea would be. And I can pass this slide. And this is the prototype that I built for the card game. You see, so not much similar to what I showed in the beginning, but also it resembles a little bit, you know, so cards, one card play against the other. This was very, very important. These prototypes are very, very interesting and important for us to make the final decision, because you got the team to play, you got the pin to test. Not the final version, but we could already get a sense of, you know, how replayable this could be, how fun it could be, and so on and so forth. So in the end, you already know the end of the stories because I showed the video, but we chose the card game. And the main reason for the card game would be that, well, using a card game that can be multiplayer, you could make way more use of Firebase capabilities, while in the Ares Dash game, basically just Flutter would be showcased because, well, maybe we could use Firebase for a leaderboard or something like that, but in a card game, we would use Firebase for all the game because it's a multiplayer. And also the Ares Dash, we thought it could not fit the requirement of being short because, well, we can be, you know, can have a Hawkeye and spot dash in the first second, or you can be, I don't know, 30 minutes trying to find it and don't find it. So, well, we went for the card game in the end. And of course, we fitted the requisites there. So we decided to use generative images models to create the illustration of the cards, and use a language model to create the description. So if you play the game, you see that it has that illustration of the card, and you see that there is also description. So like if it is a dash wearing a parrot hat, there is a fun message that were generated by machine learning models. Cool, so Now that I explained you the ideation process and how we got to this, let me tell a little bit about the technical parts. So we split the work for this project. So this project was done in partnership with Very Good Ventures and Google. And Google was responsible for doing all the machine learning work that we would consume. Because, well, they have the TensorFlow team that partnered with us to make that happen, and we don't have much knowledge on that, so it made sense to be Google who was responsible for that part. And VGV, we've done all the game itself, the client, the backend, and all the interactions with the users, integration with the API that Google provides to us in the end. And here, I'm going to tell you a little bit about the tech choice that we made, why we choose to do the things the way we done. So the first one, we knew that we had to have a backend, right? So this would not be just a game that would run on the player's cell phone. That would be a backend for it. And why we did that? So first, we need a leaderboard. So this would be a competitive game. So players would compete against each other. We need that information to be somewhere centralized. It cannot be on each player's cell phone or browser, actually. You wanted to have at least a kind of anonymous authentication there, just so people don't exploit and try to do the DOS and things like that. Just you don't have any account, but you just want to use Firebase anonymous authentication to try to prevent any type of attacks and stuff like that. And those machine learning services that Google do use was something new, so that were available to the public ad. So the client would never access that directly, but it would access through our backend. So those services will not be exposed to the public, so people, we basically want to avoid people trying to inspect, open Chrome developer tools, on network requests, and then trying to use those services to play, or maybe try to destroy our servers and stuff like that. And also, this is a game, a competitive game. Players would play against each other. So we wanted to have this game to be a server alternative. What does that mean? This means that the server decides who wins, who loses. Although the client, and I will talk more about this in the next slides, but the client knows the logic of the game, but who decides, who writes on the database, who wins, who lost is the backend. So this basically prevents cheating, like people try to understand reverse engineering the API calls and try to forge something. So this is done in the backend. They cannot do that from the client. And then once you decide that you'll have a backend because of the reason, where will that backend live? So that was the next question that we had to answer. And the first thing that we thought, is on our requirements. We need to use Firebase. So Firebase provides a bunch of backend services for us. So we will use Firebase. So we're going to need to store data because the data for the games, the data for the cards, for the leaderboards, it provides to us. So that's a check. It has real-time updates. So we're going to make this game be play between players, so we need real-time updates. So when one player plays their card, the other player needs to see the card play. Firebase has a lot of real-time update features, so that was another check. And Firebase also has authentication and app check and all those stuffs to fulfill that requirement for anonymous authentication. It also has the file storage, which we use to store the images of the card that came from the API. So Firebase was a great choice for supplying our backend. But Firebase provides you services. You still need to write the logic, right? So the backend needs to receive the cards play, calculate which one wants, then write. So you need to write that logic somewhere. The first thing that we thought was to use Firebase functions, right? Because it allows developers to write custom backend logic. It has a smooth integration so it's super easy to access Firestore, to access authentication, whatever, from a Firebase function. But the only thing that it kind of left us a little bit undecided was that there were no Dart support for Firebase functions still. I think that at this time it still does not have. And Normally, that would not be a problem, right? TypeScript, JavaScript is not that hard. It's not a bad language, so it's not automatically a problem. But for us, it was important because the team, our team at Very Good Ventures, they are Flutter developers. Most of them started their career with Dart, with Flutter. So learning a new language is not complicated, but learning an entirely new environment ecosystem. So when you are working with Java, with TypeScript, it's not only the language, but you need to learn about transpilers. If you use TypeScript, you need to understand how their testing framework works. So it would be kind of a heavy lift to hump the team in a new language in a project which we had a short time to develop. So for you to have an idea, we had 3 months to develop this from ideation to delivery. So that would be important if we could use the language which the team already had knowledge. And also, this is a bonus, of course, we don't need that, but using Dart would enable us to share code between backend and frontend, which we did and was great, and I'm going to show a little bit more in the next slide. So, but to sum up, this is why Dart was important for us. You know, like basically the developer experience was the prime factor there. We want the developers to not have to learn a new entire ecosystem to develop this project. And this is the idea that we come up with. So we could use Dartfrog, which is a backend server, a backend library on top of Dart that we also develop at Very Good Ventures. It's open source, so if you have any curiosity to check it out, you can check on our GitHub, on our website. And we decided to use Cloud Run from Google. That would also make us use a new Google project. So that would make a new bonus for the showcase of the project. Awesome. And then we choose that. That made it, Cloud Run makes it so easy to deploy and scale. So I don't know if you know Docker, but it's a very common thing on the backend world where it's easy for you to create your environment and to replicate it, and Cloud Run supports it. Also, Dartfrog already comes with support out of the box for Docker. So that was something that made it easy for us to make this choice of Dartfrog and Cloud Run. It is not as smooth as just using Cloud Functions to access the Firebase services because, well, Cloud Functions, it's inside the Firebase platform. This is on Cloud Run, on Google Cloud platform. So it's not a direct access, but it's close enough because all the Firebase Cloud Functions actually run on Cloud Run. So the infra is there, but you need to figure out some pieces of bits, which was kind of easy to figure out once we had made the right question to the right people. But keep in mind that it is not as smooth as is on Firebase Cloud Functions. But you can get there as a little bit of research. And that enabled that great developer experience that we wanted so much, which was the issue with using JavaScript Cloud Functions. So that was our choice and why we chose to do a Dartfrog backend with Cloud Run. And on the front end, we made the game with Flutter, of course. And to get the game started, we used the Flutter Casual Games Toolkit. I don't know if you ever saw this, but this is something that was released, if my memory serves me well, on Flutter Forward early this year or last year. I don't remember. I'm getting old. My memory is not helping me anymore. But this is something that we can, if you go to the games page from Flutter, Flutter has a dedicated page for game development. And Flutter Casual Toolkit is basically a template for you bootstrapping your game. It has a bunch of common features like a title screen, a settings page, a stage selecting page. It already integrates with ads, so you can monetize your game through ads if that's the way you want to monetize it. It already has full integrated audio support with already handling the life cycle. So if you put your app in the background, the audio pauses, because that's not something that it happens automatically. So it's a great template for you to bootstrap your game. And in line with that idea of showcasing Google things, of showcasing, good tech that you can use to build games, we started our project with this template. And it was great. We weren't able to use all the features that the template has, because the template is more focused to mobile games, so we will not use the ad kits things, like the monetization. There is no monetization in the game, so that's something that you could not use. It also has integration with the stores, with Google Play and the Apple Store. That's also something that we didn't use, so we had to scrap that out. But it still got us up to speed in some areas, which basically the biggest benefit for us. Oh, this slide is wrong. But I remember this slide. So basically, what gave it to us was the audio support. So it was audio. I don't know if you ever worked with audio. It's a mess. I don't know. I don't know why it's that hard. We can send the humankind to the moon, but we cannot figure out audio in computer. So I don't understand that. But in any case, it got that configured to us with the life cycle. So if you close the tab, if you change the tab to another one, it will pause the game, the audio music for you. It helps us with the Firebase setup because that comes along with the template. And some of the screens are right there also. This is just to show off a little bit, because we use shaders in this project. It was very cool because when we released this, shaders was not in stable still. It was in beta. But we knew from Invertase that was going to stable. So hey, this is a good opportunity to use shaders to showcase this new release. So if you get a rare card, a card with top power, with 100 power, that card will have this holographic, I don't know how to say that in English, I think it's holographic, this holographic style thing. So yeah, just to mention that we were able. Also, it's worth mentioning that using shaders in Flutter is super easy. It's even scary a little bit. Like if you know how to write shaders, which is the hard part. Like, I don't know how to write shaders. I didn't wrote this, so I'll not take credit for that. It was a member for our team, but they wrote this from scratch, and once the shader was done, it was just a matter of putting a widget, link the asset file for the shader, and you got this. So if you never tried shaders, you should. It's super fun. Using, not writing. Or if you want to write, Hannah knows a lot. This guy knows a lot about shaders. And another choice that we made was to use WebSockets because, well, these were a multiplayer game, right? So 2 players compete. What happens if one player leaves in the middle of the match? It would be a very bad user experience if the player that was still in the match would stay there forever and waiting for their opponent to play. That never happened. So we decided to use WebSockets to do the checking of the user, the player's presence. So when both players went to the match, a WebSocket connection would be open, one for each one of them. And WebSocket connection, for those who don't know, is a persistent connection, so it stays open as long as you keep it. You are the program, so decide that as long as the match is going on, we would keep this connection open. And if that connection is lost, the server would know that, and we would know that one of the opponents, one of the players left, and we could act upon that. In this game, we choose to make a CPU take the place of the opponent, because this is a short game, a very short game. It should last like 30 seconds tops, because you have 10 seconds to play a card, and there are 3 cards, so you should not take more than that. So we figure out that it would be better if a CPU would take over than for the player to, the other player who was still in the match to lose their play session. So this was another choice that we made and worked awesome, because both Flutter and Dartfrog supports WebSocket. So this was something worth noting. And of course, we are using Firebase in the backend, as we mentioned, as our data source, authentication, and all that stuff. So we are also using Firebase in the client. And on the client, we did use also authentication, app check, to make sure that the requests that were being sent to our server were coming from a client that was configured correctly with the Firebase credentials and all that. And one cool aspect is that, like I mentioned before, this is a server-authoritative game. So you would think that all the information would be done via the backend, right? Because if the client access directly the Firebase database, we are doing operations on the client side. We would be against what I mentioned before. But we kind of divided that the data can be read from the client. So that allowed us to use the real-time updates from the database on the client, which allowed us to make the game faster. So the game on the front does not need to call our backend to get information to display. It accesses directly the Firebase, the Firestore database. And we solved that, we made that safe by using Firestore rules, right? So if you are reading the data, you can read from the client. If you're writing data, you need to write from the backend. So that's how we solve that server iterative and requirement and how we access the data from the client. I'm gonna go a little bit more on next slides about this, which I should show this first. So this is the macro view of the project. So we have the game client, the Flutter game client, and you see that it access the Firestore database, but just to read information, which makes the game client dummy, right? So like they know how to read the data, they know how to interpret the data, but they are not writing any data. This is the backend's job, to make it safe to avoid people from cheating. The game backend, which is made in Dart Frog, it does all the writing, it does all the calculation of the match. So when you post your move, or when the other player posts their move, it's the backend who calculates for everyone. And the WebSocket is also an interaction which happens with the game client and the game backend. And in the end, we were not able to make the generative images and text be in runtime because that proved to take a long time. So we wanted this to be fast, and we didn't want the player to wait 20 seconds for the cards to be generated. So we pre-generated a bunch of illustrations, like 400,000 images, something like that. And descriptions were 2.5 million combined with, and that would give like, I can't even do the math for how many combinations there. So in the end, we chose to pre-generate all that data, fill our database with that data. So the images went to cloud storage from Firebase, and the descriptions, the text, the names went to Firestore, which also, it's often mentioned that it took me like 3 hours to upload everything. So that was a fun thing to do. I had like 15 terminals in my screen. It was fun to do. My internet provider was not happy, but well. So that's a macro view of the game. It's kind of simple when we look at this diagram. And now I think this is the most fun part. So like what worked well, things that we proposed in the beginning in the project that we weren't sure but worked great, and also some things didn't work so well. So I'm gonna tell you about all those. So the first one, which is my favorite, is code sharing is awesome, really. Like from my career, I heard a lot about code sharing in many languages. I started by hearing that with the Java world, where people used to do Java in the front end and on the back end, and people said code sharing between front end and back end. I never saw that working well. People talk about that a lot with Node and React, and not only React, but any front end platform library that relies on JavaScript. So I never saw that working well as well, but we managed to make that work well in this project. The thing that I liked the most is that we were able, because we did this code sharing, so the game logic is exclusive in a single package. So all the game logic is in its own package, which the backend and the front end uses. So even though the backend is the one who you write, who win, who lost, it's the backend who decides that, the front end can know that. And by knowing that, we can implement optimistic-wise, which improves a lot the experience of the user. Which I show in the next slide, but first, this is a very rough diagram on how we made this package. So we created this package called Match Solver, which both of the parts of the project, both the claim client and the backend. So basically, what does this package does? It calculates the card modifier with that. It is that elemental damage that I showed in the beginning. So this is the routine that tells that water beats fire, that water beats earth, and so on and so forth. And do basically all the logic. It calculates the elemental damage, it calculates the power, comparison, and check whoever wins. And the backend does the same thing because it uses the same package. And of course, it also validates the input of the client and things like that. And hopefully, in this video, I can show you better how this works. So you see that the result is instantaneous. You know, like the game shows whoever won in an instant. But there's a request being made to the server, which takes some time because network latency. But since the game, the client knows who will win this round, they don't need to wait for that request to complete. So that's what we call optimistic. Why? Because it is optimistic that this will work. You know, of course, if the request fails for some reason, for I don't know, the internet connection got lost in the middle, it will hold back and try to do it again, but for 99% of the case, the request will complete, and the result that will come for the server will be exactly the same that the client calculated. So this gives us a better user experience, and is what I think it was the most cool thing about code reusage. Of course, the productivity of the team was also cool, because when we found a bug in the game logic, we didn't have to go to the backend, fix it, and go to the client and fix it, and so on and so forth. But for me, the value that this brings to the user experience is what is the most cool part of this code sharing. And another awesome win was that Firebase and Google Cloud work great. So we were a little bit worried about that when we decided to go back from Firebase functions. But as I mentioned before, Firebase functions, Cloud Functions runs in the Google Cloud infrastructure. So in the end, that worked better than we anticipated. And this was the compromise that we did, losing the pros of Firebase functions. It wasn't that bad. So that was another win that we did, and it was very cool. And this is some graph that I want to show you, which I think is super interesting. So this is the graph of the Cloud Run instance of the game backend in the day of the event. So the game was announced live on Google I/O, and this peak, this climb that you are seeing is the moment that they announced the game live on the screen. And you see that there is 0 errors. I'm so proud of that, because 0 errors, 0 downtime. It worked. Thank you. Yeah, so this shows how good Cloud Run scales, because we just configure the min instance, the max instance that we thought would be enough for the launch. And when the game had a spike in usage, Cloud Run scaled. It started, booted new instances, and handled everything for us, 0 downtime. It was super cool to see that. This is the same graph from the same time moment, but here I think it's interesting to see how Cloud Run was working, because here we can visualize that once the peak of CPU utilization reached a certain level, it started to boot new instances, and that would start to normalize. So it's the same time frame, but a different view with different information, which shows how well Cloud Run was able to scale this. This is another super cool graph. The Puff, is Puff here? No. Puff showed me this on the day of the event, and it is a graph from Firestore that I have never seen before in my life, but it's super interesting. It's a little bit confusing to look at a first glimpse, but it's so beautiful. I don't know, I think this is so beautiful. The colors and all. And here is basically the access of your Firestore documents. So here are the numbers with requests per second, and here on the other, on the left side, we see the documents. So this was a cool thing for us to analyze, because when we started this project, we predicted that most of people will just play if you generate card. They will not even play the game because it's fun, you know. The cards are random, the images are, there are so many combinations. So I thought, hey, people will just keep playing, keep generating new decks and seeing what they come up with. And this showed this was true because card descriptions and prompt terms are the entities that we use to do that generation. So this was a cool graph to look to prove a prediction that we made in the past. So if you don't know this, this is available only on Google Cloud dashboard. So if you go to Firestore, you will see key visualizer there. You can see this information. And another thing that this was also Puff that mentioned to us is that when you're using Firestore and you know that you have a spike of usage, you need to ramp up your Firestore instances. This is something that we can find on Firebase on Firestore documentation, which is basically the warm-up of your Firestore. Because Firestore, the way Firestore works is that once you reach a certain amount of usage, it pumps you a tire of scaling, and you never go back. So if you go to tier 1 to tier 2, you stay that tire forever, even though if your app is not having at that moment that much access. So what we did was just make a script that basically was firing against our instances until it reached the top tier of scaling. And that was something that works well and made sure that we had zero downtime, you know, because if that happened during the spike, some people might have stay on that downtime of Firestore scaling to the next tier. So did that previously, that was not an issue in the release day. And this is also something that was super cool to do, that is worth sharing, is that I think it's common knowledge that when you are doing stuff, you need to keep iterating, test, adjust, you know, get a feedback, act on that feedback, and adjust the product before doing the release. And one of the things that we were not really sure was the final version of the game logic. So we had many ideas, like, for example, instead of elemental damage, we could maybe just be like a handle value, like a dice thing, you know, like a luck factor. We were thinking on many different game logics. And we wanted to test those variations before decide which one to go. So all the game is written in a scripting language called Hitu. I'm not really sure how to pronounce, but it's H-E-T-U. And it's a scripting language written all in Dart. It's pure Dart, so it works on Flutter, it works on Dart Fire, because it's just 100% Dart. And with that, we were able to change the game logic without doing new deploys. So we were able to get the designers of the project, put them to make some play testing, gather their feedback, then change the code a little bit directly from the web. We built, this is for real, this is a live editor. This is not enabled on production, so you don't have access there, so don't try. But with this live editor, we were able to change the game logic without doing any deploy, which was very productive for us to test different variations of the game logic and decide for the one that we have in the game right now. And now what we learned and what didn't work that well. A sync program is so freaking complicated. I think that sometimes we underestimate how complicated a sync programming is. So for the simple case, when you are just making a call to API, waiting for the result to come back, then react on that, it's not that complicated. But when we're talking about like a multiplayer games, when things are happening at the same time, it gets so difficult, and we have many problems because of that. And one of those problems, for example, to put an example, we had a weird bug where you play your card, your opponent play your card, everything seems to work, but then the game reacted as your move was erased. You know, like it seems that you play your card, your opponent played, but then your card was back to your hand. And this was happening because even though the events were being fired at the correct order, when they came from us, from Firebase real-time updates, they were in different order. So your your update was arriving back to the client after your opponents, which didn't have your move. So basically, the order were wrong. So you should never assume that the events that we will receive will be in order. So always check. In the end, the fix was super easy. Basically made a simple logic to check which is the newest state. And if we receive a state that's older than the one that the client already have, we just cut it. So the fix was super simple, but it took a long time for us to debug it to understand that that was, because it's not something that you can really debug with a breakpoint. Because if you put a breakpoint, your code will stay there, and the timestamps will be even bigger. So yeah, this never assume the events will be in order. If you're doing something asynchronous that events happen at random times, never assume it will come for you in order. And also, this was very problematic in the matchmaking. So our matchmaking logic, we thought that should be simple. Like, so I have this quick diagram to show how it works. So it's a two-player matchmaking. So it's supposed to be simple, right? We don't need to like those games that have 4 players where you have to balance the things and worry about their ping, about their location, all those. So it's not that complicated. It's just 2 players. So how do we thought to make it? Basically, when you start a match, we check if there is an open match. And this is all done via Firestore entities. So when I say if there is an open match, I'm checking in the match documents if there is one match there that has just 1 player. So if there is, it tries to join. And try to join means I open a transaction and check if I can make it, because maybe 2 players are trying to join the same match. And if that fulfills, both players go to the match and then play. If it fails, it try again until it can find a new one. And we also did a checking that if you try like for 4th time, something like that, we match with a CPU. Because it's a short game, it's better for you to go play against a CPU instead of keep trying. And we made that. It worked great. But once we start to make the loading testing of the game, the matchmaking simply didn't work. Like, there are so many handle events happening. States arrived at handle times. So this was specifically bad in this. In the end, we solved by doing a load balance. So a percentage of the players would automatically go to a CPU match, while some of them would go to the matchmaking routine and try to find a player. This was not the best thing for the player, but we need to learn this, and we try to do this compromise. But yeah, this is basically just a message that I want you to if you try to make a multiplayer game, don't assume like events will come in order. This is simple. Even a 2-player matchmaking is a complicated thing to do. And that's it. Thanks so much for hearing my story.